Hello and welcome to the first in a set of videos that are going to look at algebraic expansions. Now, for the most part, these expansions are going to be a review of what you've done in previous years at school, I would imagine. But the examples I use hopefully might bring it to the next level. Maybe not, we'll see how we go. So you can see on the screen there are three success criteria here. We've got that you can expand two or more expressions, and I'll talk about that in a second. The second is recognizing and expanding a perfect square, and the third is recognizing and expanding a difference of two squares, that's dots. And I guess the key outcome there is, for those last two dot points, is that you can see an expression and go, oh yeah, that fits the pattern of a perfect square, or that fits the pattern of a difference of two squares, even if it's unfamiliar. And that's a real key to success there. And we'll expand upon that as we go along. In this video, we're going to just focus on your basic expansions. And then in subsequent videos, we'll have a look at those two different sort of particular patterns, perfect squares and difference of two squares. And we want to get you to the point where you're not always reaching for the basic method of just doing a straightforward expansion. Although that will always work, it's slow and therefore it's not efficient. And what we want to instill in you in maths methods is an efficiency to your processes for really good reasons. And that is, number one, the less time you're spending on the actual, run-of-the-mill calculations, the more time you can be spending on more complex stuff. And number two, just for a pure mercenary approach to how do I do my best at exams, if you're working efficiently in exams, you're freeing up time to work on more difficult problems. So we want to get you to that point. Okay, so there's a success criteria. And as I said in this video, we're going to look at your run-of-the-mill expansions. Bit of theory to start with. So binomial expansions are when you've got two or more binomial expressions multiplied together, and a binomial expression is simply an expression with variables or terms that have been added or subtracted together. There's only two of them, hence binomial. Trinomial have three, etc. Okay, so we've got a binomial expression here, a plus b, and a second binomial expression here, c plus d. And how do we expand that? And expand that effectively means get rid of the brackets, as you should be well aware. I won't try and dwell on the basics too much. Now, there are two methods that I would propose. You should be familiar with both. You are welcome to only use one of them in most cases. The method that you would be most used to thinking about how it works at the friend school, at least, is that we use the box method. So we draw a box, and I can see, because it's a binomial multiplied by a binomial, then I'm simply going to have a, and if you like, plus b on one side of the box, and c plus d on the other side of the box. Now, if they're not binomials and you're expanding them, then the box arrangement is a bit different, and I'll show you that next page. Then what you're doing is you're filling in each of the boxes here. So we've got a times c is ac, b times c is bc, a times d is ad, and b times d is bd. And so your final expression becomes AC plus AD plus BC plus BD. And that's basically it. I haven't written the answer down because I want to show you the final answer using the second method. So this is all fine. Its bonuses are that it's a really clear visual way of seeing the different parts of the expansion that you need to put together. The second bonus is that when we do something a little bit later in this unit called polynomial factorization, then, or polynomial division specifically, then this method is really useful to do in reverse. But we'll get to that a little bit later in the course. So be familiar with the box method because it's really useful later on. The other method is to use what I call the chicken beaking method. I didn't make up the name, but I call it the chicken beaking method, and you'll see why. And it relies on the basic premise that effectively an expansion is multiplying everything in one set of brackets by everything in a second set of brackets. And that's it. That's basically how you expand. So I'll do this in blue so you can sort of see the difference. So I multiply A by C and multiply A by D, like so. And then I multiply B by C and multiply B by D. And the reason why we call it the chicken beaking method, it's a bit silly, I know, but the chicken beaking method is because this is like the top beak of a bird, this is like the bottom beak of a bird. So, this way maybe, chicken beaking method. So we follow the blue lines along, and we see we've got A times C is AC, we've got A times D is AD, we've got B times C is BC, and B times D is BD. Now, the benefit of this method is that it is faster, effectively. And you've still got some visual cues there with the chicken beaking, but as you become more practiced, you probably don't need to write the chicken beaks in. You can just do it by sight. If you do it methodically, you won't miss anything out, and it's a little bit quicker to do. Okay, so down in the left-hand corner there with example 1, let's use both methods to see this done really quickly. So because it's new, I'll do the chicken beaking method first, which is x squared times x squared times minus 1, 1 times x, 1 times minus 1. And do note that the sign does follow the term after it. So the minus goes with the 1 here. So x squared times x is x cubed. X squared times minus 1 is minus x squared, because a positive times a negative is negative. 1 times x is x, and 1 times minus 1 is minus 1. And we do a quick check, and yep, there are no like terms, so that's our final answer. Instead, I'll do in the last box down, this is not example 2, I'll get rid of that. Instead, I could do it via the box method, like so. So we've got x squared plus 1, we've got x minus 1, and now we just fill in each of the individual boxes. So x squared times x is x cubed, 1 times x is x, positive x, minus 1 times x squared is minus x squared, and 1 times minus 1 is minus 1. Okay, so then we just write it in underneath. Well, this can be written off to the side if you like. I'm sure you're probably familiar with doing it, so you've got your own methods there, which is absolutely fine. So the final answer is x cubed minus x squared plus x minus 1, which of course is the same answer as I got using the chicken beaking method. If you don't get the same answer, it either means you've made an error in one of the methods, or the universe has ended. So hopefully the universe hasn't ended. By the way, just in terms of neatness, I suppose, is an appropriate way to say it. You'll notice that I've just ended up with my variables in descending powers of x. That's just normal. So that's power of 3, power of 2, power of 1, even though the 1's not written in, it's implicit. And x to the power of 0 is 1, so it's like a power of 0 there. So writing them in descending powers of x is, or whatever the variable is usual. And within terms, remember that A, B, C, and D could be anything, including they could be all the same value. We don't know because they're unknown. But typically we write them in alphabetical order just so that we can see like terms a little bit more easily. So typically alphabetical order, typically in descending powers if there's only one power. Okay, let's have a look at a couple of more trickier examples, and then I'll end up the video for this one. So example 2 here, we've got a binomial multiplied by a trinomial here. It's the same sort of approach. I'll do chicken beaking to start with, and then I'll move to the box method so you can see how that works. So it's like a striped chicken beak. It's it is x times x squared, x times 2x, x times 1. And by the way, you don't have to do all the lines first. You can just do a line, and then I'll do it for the bottom so you can sort of see there. So I'll do that first. And I want to show you a particular way of setting this problem out as well. So we've got x times x squared is equal to x cubed. X times 2x is positive 2x squared, and x times 1 is x. Okay, fantastic. And then I'm going to do the second chicken beak. So I'm going to go 1 times x squared is 1x squared, so it's just x squared. But what I'm going to do is, rather than continuing here, I'm instead going to just write it on the line underneath, like a column addition. So because it's an x squared, I'm going to put the plus x squared here, and you end up with a column at, which is so neat and so easy to see where you're going. And then I've got 1 times 2x is 2x, so we've got plus 2x again, keeping my columns together. And then finally I've got 1 times 1, which is plus 1. So I end up with this nice easy column at. I'm looking down the columns here to collect my like terms. So I've got x cubed, 2 plus 1 is 3x squared, x plus 2x is 3x, and the plus 1 is my final answer there. See how neat that is? I'll use the box method as well, just so you can sort of see what it looks like. You've got a binomial multiplied by a trinomial. So rather than drawing a square, I'm going to draw a rectangle. And then because I've got a trinomial, I'm going to split one of the sides into 3 and then one of the sides into 2. So I'll put the x plus 1 here, and I'll put the x squared plus 2x plus 1. I like to put the operations in as well because it doesn't get me confused then. And then I'm going to fill in the boxes. X times x squared is x cubed. 1 times x squared is x squared. X times 2x is plus 2x squared. 1 times 2x is 2x. X times 1 is x, and 1 times 1 is 1. Now, the thing I like about the box method here is that the diagonals will give you the like terms. So I've got an x cubed here, then I've got my x squareds here, I've got my x's here, and I've got my constant term, that term with no variables in it, here. And so as I look along the diagonals, I just add them up. So I've got x cubed, x squared plus 2x squared is 3x squared, 2x plus x is 3x, and plus 1. Like so. And looking at it, I can see that I've got this expression and this expression exactly the same. Hooray, must be all right then. So which method do you use? It is entirely up to you. This one is a little bit more compact, but is prone to maybe making typo errors kind of thing, unless you're careful. This method is much more visual, but takes up more room. Which method do you use? The method that you think would work best for you, but stick to something and practice it. Make sure you're at least familiar with this though. Okay, example 3, I've got a binomial times a binomial times a binomial, so we've got 3. How do we tackle that? Well, ultimately, if you think about the operations, the basic ones, multiplication, division, addition, subtraction, they are really what we call binomial operations. And that means they are an operation which takes in 2 values and then produces a result. Like for addition, produces a single result. Multiplication, 3 times 7, a single result of 21. So when you've got 3 here, just like we do with the standard numbers, we just pick a pair and do those first, and then take the result, and then use that result with the third bit. So how do we do it? For the box method, I don't think I'll do the box method this time because ultimately it gets a little bit repetitive. So I'll stick with the chicken beak method. And what I would probably do is I would probably, multiply the right-hand side 2 first. It ultimately ends up being a little bit more efficient. So let's see how we go with that. So the right-hand side 2 are x plus 2 times x minus 3. So I go x times x. So I've got equals x plus 1 multiplied by x squared. And then I've got x times minus 3. So I've got minus 3x. Okay, and now I'm going to do the bottom chicken beak. 2 times x is plus 2x. And 2 times minus 3 is minus 6. Okay, so there we go. I've now expanded it. I didn't bother using the column method that I did in example 2 because it's simple enough to not worry about. So I'm left with this kind of expression, and always at every single step, if you can simplify, do simplify. Now, when you get a little bit more experience, or maybe now, depending on how strong you feel you are right now, you might get away with doing this in your head, okay? But what's this? Sorry. You're doing it in your head. You're going x times x is x squared, and then I've got 2 times x is 2x, and x times minus 3 is minus 3x, 2x minus 3x is negative x. You're doing all that in your head. That's okay, as long as you can consistently get your problems right. If you're not consistent, or you're a bit unsure, do take an extra line like I've done here, this one here. And then the final line, before I move on to the next step, is x plus 1 multiplied by x squared minus 3x plus 2x is minus x, and then minus 6. Okay, so that's my first part of my expansion done. And again, this bit here, which I will just put a little star next to and put optional. Again, if you're feeling confident, you can absolutely go from here to here by doing this bit in your head. Okay, it's up to you. If in doubt, put the extra line in, particularly when there are negatives involved. I find when there are negatives involved, that's when you can make some mistakes in your head. Now we'll do the next expansion. I think I'll do a column add this time. So I've got x times x squared is x cubed, x times minus x is minus x squared, and x times minus 6 is minus 6x. Then I've got 1 times x is x squared, 1 times minus x is minus x, and 1 times minus 6 is minus 6. Okay, so then I can do my finish off with my column add there. I've got x cubed minus x squared plus x squared is 0, so there are no x squareds left, so we leave that blank. Minus 6x minus x is minus 7x. You don't really need to leave this big gap here, but I'm just trying to keep the columns true, and then a minus 6 at the end. So the answer is x cubed minus 7x minus 6. So you don't have to, but if you just wanted to make it nice and tidy, rewrite it again with the gaps missing, and you're done. Okay, I'll leave it there for this video. That's your basic expansions. There are some problems in the textbook. Refer to your work schedule, which just deal with these sorts of basic expansions. So refer to your textbook for that, and then have a look at the next two videos, which are on difference of two squares and perfect squares.